Hey guys, this is section 16.1, properties of logarithms. So we just learned the definition of a logarithm, right? And we can go back from logarithm expression to an exponential expression, right? We can go back and forth between the two. You need to be familiar with that in order to understand this section, which explains a lot of different properties of what we can do with logarithms. Okay, there's a lot of different things we can do with them that's going to help us simplify some expressions. So the first thing I want you guys to do is get a calculator if you don't have one already. Get yourself a calculator because we're going to do these calculations right here on the very first table with the calculator to try to investigate these properties. Okay, so if you don't have one, go ahead and get one right now. Once you already have a calculator, what I want you to do is go ahead and evaluate all of these expressions here using the calculator. Okay, it's a scientific calculator. You can use the graphing calculators in the classroom. And what that means is go ahead and do the calculations here. So for example, for this first one, I would do 10 divided by e first, and then find the logarithm of that, right? And then just write approximately what you get. Let's say to 3 decimal places should be good. And then we can just look at all the numbers that we get. So this one's pretty easy. Just find the natural log of 10. This one, what I would do first is do e to the 10th first, e to the 10th power, and then find the log of that to see what you get, and so on. Okay, so go ahead and try those out. So take a couple of minutes. It shouldn't take you that long. It's just punching into the calculator and get all the different approximations for each one of these. Okay, figure out what each one of these. So go ahead and pause the video, do that, and then we'll come back to see those answers. Okay, so hopefully you got them all done using your calculators. These are the numbers that I got. If you didn't get these numbers, go ahead and maybe double check the way you're calculating the numbers, because sometimes there's little issues here and there that you might come up with when you're trying to calculate this with a scientific calculator. So for example, like on this one, I went ahead and did log of e first, and then whatever I got, I said 1 divided by that. So that gave me 2.304. Okay. In this one, I did 10 times e first, whatever that is, and then I took the log of that number that I got, and I got 1.434. So if you're not following the correct order of the operations, maybe you're not getting the same numbers that I did. Okay. So the point is here to look at what you got and see if any of them are equivalent to each other. Okay, remember the word equivalent, meaning that they have the same value, and you should be able to see that a lot of them are, right? So for example, I'm going to go ahead and draw some connections here. These two are the same thing, right? 0.566. Also, these two are the same thing, and these two are the same thing, and these two are the same thing. Okay, so setting those expressions equal to each other gives me some of those equivalent expressions. So watch. Let's start with that first one that I did in black. Log base, it's base 10, right? That's a common logarithm. Log of 10 over e is the same as, I'm looking at this one right here, is the same as 1 minus log of e. And there's a few more. I'm gonna write them all down. Use make them fit in your paper in this area if you can. I can't write that small with my stylus, but you guys can probably write a lot smaller than I can. So make them all fit. We're gonna write all 4 of them. That's only the first one. Right? The next one is this one. Let's do that one next. Okay. Oh, you know what? No. We just did 1 minus log of e. Let's do the other one that is similar to that one, 1 plus log of e. So let's do these two next. Okay, so I'm going to write that one next. Log of 10e is equal to, and of course again it doesn't fit on mine, but you guys can make it fit on yours. Log of 10e is equal to 1 plus log of e. And the next one, I'm gonna write it wherever I can fit it. You guys have, I keep saying that, you guys probably have enough space to fit them all 4. I can't write that small with the stylus. The next one I'm going to write is this one that I skipped. ln of 10, natural log of 10. ln of 10 is equal to 1 over log of e. And the last one, let me see where I can fit it. I'm going to write it down here. Right here. The last one is that bottom one, log of 10e is equal to 1 plus log of e. That one. Oh no, that's the wrong one. We already wrote that one, right? The one we're missing is this one right here. Let's do that one. Log of e to the 10th power is equal to 10 log of e. That's the one. So what does it all mean? All of these are basic properties of logarithms. All of these will we came up with them using basic properties of logarithms. Okay, we used calculators to notice that they're exactly the same, but we could actually come up with some definitions of these things. For example, one of the simplest ones, which is I think one of the first ones I'm going to explain, is this one. Whenever you have the log of any number with any base, it doesn't matter what the base is. In this case, it's 10, but the base could be e or 5 or whatever. Whenever you have the log of any number and that number is raised to some power, then you can take that power and bring it to the front, like they did here, to turn it into 10 log of e. Okay? And you could do that every single time. That is one of the properties of logarithms. It's actually right here. It's the power property. See what it looks like? Log base b of m to the n power becomes n times log base b of m. So they took that n and it actually just moved it to the front so you can actually multiply it out. But there's a few others. Let's go through each one and then we're going to use them all to simplify some expressions. Okay. For example, these are basic properties. These are based on the definition. Log base b of b to the m is equal to m. Why is that true? Because that's basically the definition, right? If I change this into exponential form, the base is b, right? That's the base. The power is m, and it equals to this whole thing right here, which is b to the m. So you're just saying b to the m equals b to the m, which is true. Right? So the way you can look at that is that every time you have the same base and the same input here, the same value, then what you get is basically what is the exponent of that base, of that number right there. So log base b of b to the m power is just m. This next one is also pretty obvious because if you look at it in exponential form, that means b to the 0 equals 1, which is true. So the way you should look at it, this one is that every time you take the log of 1, regardless of the base, you're always going to get 0. Okay? Anytime you take the log of 1, regardless of the base, you're going to get 0. Same thing for that one. It's pretty obvious. If you look at it in exponential form, that means base b, b to the 1 power equals b, which is true. The way you should look at this one is whenever you have the same base and the same input, you're always going to get 1. Okay? So a lot of these are going to take you a little bit of time to get used to and to practice. That's why we're going to practice a lot of different problems so you guys can see them all being used. Okay? Then what we have is the product property and the quotient property of logarithms. Product property and quotient property. Those are actually usually pretty easy for people to understand and to see. Okay? Log base b of m times n, that means that you have a base and a product here, m times n. What you can do when you have a product right here is that you can split them up into two logarithms, one for m, one for n, like this, keeping the base the same. See that? Same base, but now it's log base b of m plus log base b of n. Where did the plus come from? Came from the multiplication of m times n. When you multiply these two numbers, it turns into the addition of two logarithms. This other one is very similar. And you should now kind of see the relationship, right? Multiplication means adding. It's kind of like exponents, isn't it? Division means subtracting, but it's the same thing. Same base. M over n means log base b of m minus log base b of n. This is the one that I mentioned before. Whenever you have a log with some base and then your number is raised to some power, you can take that exponent and just bring it to the front. Bring it to the front and you get this new expression. Okay, and the final one is one that I really want to practice with you guys in class in person, because it's one that people you need to get used to. Okay, it's called the change of base property, which basically says that you can change the base of any logarithm to whatever you want. And this one is very, very useful. Okay, remember, like I said in class, most scientific calculators only allow you to do two different bases, right? You could do base 10 for the common log, or you can do base e for the natural log. That's about it. So if you have any other type of base that your calculator cannot handle, you can use the change of base formula to change it to whatever base you want. Okay, and it actually goes very simple. Log base c of a. Notice that there's two numbers here, c and a. Here's a, here's c. And the base is whatever you want it to be. You can choose whatever number you want here. Okay, so you're going to get log of a over log of c with whatever base you want. We're going to be using that a lot. I don't think we're using it that much in this section, but it is going to come up a lot. Alright, so I just talked about a lot of different properties, and I know there's a lot of them, but the best way to get through this is to tackle some problems, and you guys can see how we start using some of those properties here. So let's get to number 1 here. Number 1 says, express each expression as a single logarithm. So notice that there's two there. We wanted to put them together. Simplify if possible. Then check your results by converting to exponential form and evaluating. Okay, so the first thing I'm going to do is I'm going to look at this expression here, log base 3 of 27 minus log base 3 of 81. And I'm going to look up here at my properties to see if anything that I have here looks something like that. And you should see this one, right? Log base b of m minus log base b of n. See that? It's very, very similar. They have the same base. They have the same base, 3. So I can apply this property right here. This property says that if I'm subtracting two logarithms that have the same base, I can bring them together to make one logarithm, keeping the base. But what I do with these inputs for each logarithm is I do a division of them, right? It's going to be m over n. So I could do this 27 over 81. This is what it's going to look like. Watch. Log base 3 of 27 over 81. And I can simplify that because I know 27 and 81 have something in common. I can divide them both by 9 or bigger than 9. 27, right? 27 divided by 27 is 1. 81 divided by 27 is 3. So it's log base 3 of 1/3. And I can actually solve that. Log base 3 of 1/3. Remember the way we were doing this in class? I'm going to set it equal to some number. I don't know what that number is. Let's call it y or x. No, how about y? If I change this to exponential form, that means 3 to the y power equals 1/3. Okay, and then again, recall 1/3 is basically 3 to the negative 1 power, correct? Because that's the reciprocal of 3. So 3 to the y equals 3 to the negative 1. What does that tell you about y? Y is equal to negative 1. So this whole thing right here, all of this is basically negative 1. So that might have been a little bit confusing to you guys, but let's just recap what we did. I noticed that I was subtracting two logarithms. I noticed that they have the same base. So I went up to my properties to figure out, is there something that looks like that up here? And I found it here. Subtracting two logarithms with the same base. And the property tells me that I'm supposed to put them together with one logarithm with the same base, and I can divide these two numbers, the two inputs, m over n. Always the first one divided by the second one. So that's exactly what I did. I did log base 3, keeping the base, 27 over 81. Then I simplified 27 over 81 to 1/3, and then I just used the definition of logarithms to switch it to exponential form. And I have to come up with some variable up here to use so I could actually use it. So 3 to the y power equals 1/3. And then I took the 1/3 and I turned it into 3 to the -1, which is what it is. And so that gave me y equals -1. All right, let's do another one. Same idea. So I see here that I have log base 5 of 1 over 25 plus log base 5 of 625. So once again, I notice that I have two logs that have the same base. So I'm going to go up here and look at my properties. I'm adding these two logs. And is there something up here that looks like that? Yeah, you should see this one, right? Two logs being added with the same base. That's exactly what that one looks like. So this property, which is the product property, tells me that if I'm adding two logs with the same base, all I gotta do is put them together on one log and multiply those two inputs, m times n. So that's exactly what I'm gonna do over here. This is going to be log base 5 of, I'm going to multiply 1 over 25 times 625. So I'm going to multiply 1 over 25 times 625, which is, I'm going to do it over here on the side. 625 over 25, which is 25. If you don't see how I did that, just remember I did 1 over 25 times 625 over 1. Right? And when I do that, I get 625 over 25, which is 25. That's how I got that. Okay, so that means that what I have over here on this side is, this is basically just 25. So what I have is log base 5 of 25. And I'm going to simplify that. You might be able to do that in your head if you got used already to switching back and forth between logarithmic form and exponential form. But if not, watch what I'm going to do. I'm going to set it equal to some variable of my choosing. I'm going to choose x. What I'm basically saying at this point is I don't know what this is, so I'm going to call it x. It's equal to x. And then once I have an equation, I can send it to change it to exponential form. What does it look like in exponential form? 5 to the power of x equals 25. And 25 is 5 squared. Therefore, x equals 2. And we're done. All right, let's try one more. Number 3, log base 4 of 64 to the third power. Log base 4 of 64 to the third power. So what I see here is a logarithm with a base 4. That is not very useful. And your input is 64, but it has a power on top of it. So I'm going to go up here to my properties to see if I see anything that can help me here. So what do I see? Let me see. I want my number here to have an exponent on it. So what I see is this one right here. Notice this one? It looks similar to that one, doesn't it? So we're going to use that. What does this property say? It basically says that if you have an exponent here for a logarithm, so you have your base, you have your input number, and then on top of that you have an exponent, you can take that exponent and just move it over to the front. That's basically what happened. See how the n just moved to the front? It's gone from here, but now it's right here as a multiplier. So that's what I'm going to do here. I am going to move that 3 to the front. So it's going to look like this. 3 log base 4 of 64. And then I'm going to try to simplify that as much as I can. Okay, let's ignore the 3 for now. I know it's there. It's in the front. I know it's there. But what I want to focus on right now is log base 4 of 64 and what that is. Okay, So as soon as you get a little better at converting back and forth between exponential form and logarithmic form, you should be able to see what that is. But until then, what I'm going to do is just focus on this part right here and set it equal to some variable. I'm going to set it equal to x. So log base 4 of 64 is equal to x. I don't know what it is, but I'm going to set it equal to x so I could figure out what it is. Okay, so if I want to solve this, if I want to simplify this, what I'm going to do is change it to exponential form. So I'm going to do 4 to the power of x equals 64. And I know 64, it's 4 to the third. And therefore x equals 3. So how does that help me? I just came up with this is just 3. That's what I just figured out. Log base 4 of 64 is simply 3. So this whole thing right here inside the parentheses is just 3. Which basically tells me that what I have is 3 times 3. Which is 9. All of this right here, log base 4 of 64 to the third power, is simply the number 9. So let me quickly recap what I just did there. I took the 3, moved it to the front. 3 log base 4 of 64. I took log base 4 of 64 and I solved for it. I figured out what it is by changing it to exponential form. Only that part. Notice that I didn't use the 3 at all in that point. Okay, just this part right here. 4 to the x power equals 64, and 64 is 4 to the third, therefore it's 3. This whole thing is 3, so then 3 times 3 equals 9. Alright, let's do a couple more. Number 4. Log base 8 of 18 minus log base 8 of 2. Once again, we did one just like that one. It's just like number 1. We're subtracting two logarithms that have the same base. So go back to your properties, look at that, and you should come up with something like this. Whenever you subtract two logarithms that have the same base, you could bring them together, keeping the same base, and then since it's subtraction, you're going to do a division of the two numbers. 18 over 2. Log base 8 of 18 over 2. And then what I can do at that point is simplify 18 over 2. That's just 9. Log base 8 of 9. Now all of these problems say simplify if possible. If not possible, then you're done. Leave it like that. I can't simplify this, right? I can try. You can think of it in exponential form, right? This is what we have, log base 8 of 9. I'm going to set it equal to some variable. Let's call it x. That means 8 to the x equals 9. And at that point, you're stuck. There's nothing you can do there because you can't solve that. You can't figure out, you can't put 9 with a base of 8, right? It's 8 to the x power, and 9 is just 3 squared, which doesn't help us at all. So we're done at that point. This is your final answer. Alright, let's do a couple more together, and then I'll let you guys do a few on your own. Number 5, log base 3 of 9 plus log base 3 of 27. There's a couple of ways I could do this. Actually, there's more than a couple of ways I could do this. Using all the definitions that I know, all the properties that I know, there's two ways that I can think of right now that I could go through this. So I'm going to show you both, just so you guys are familiar with every single possibility that you have. Okay, so the first one is, it looks familiar to one of the properties that I used already, right? It's addition of two logarithms with the same base. So if I have two logs with the same base, I can put them together. You guys got to recall that property that we used it a couple times already. That says that I can put them together, keep the base, and I can bring the 9 and the 27 together by multiplying them. And then I use my calculator and I figure out that 9 times 27 is 243. And then in order to finish it, what I need to do is change it into exponential form. But in order to change it to exponential form, you always have to have equals something, right? So I'm going to set it equal to x or y, it doesn't matter. I've been using x a lot, so let's use y in this case. Change it to exponential form, so it's 3 to the y equals 243. And then I need to take that 343 and change it so that it's base 3. And I think it does work out. It's 3 to the, let's see, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 3 to the 5th. So that means y equals 5. And I'm done. That's it. What's another way I could have done it? I could have done it in pieces. I could do this first and then do that second. Okay, so this is what I mean by that. I am going to focus just on log base 3 of 9. Let's forget about the other one for now. Just this one. Simplify this one first. And I know I can simplify it because I notice that the base is 3 and this number is a power of 3, right? So you think about this way. You could set it equal to x and do the work again, but you can do this one in your head. It's pretty simple. 3 to the what power is 9? 3 raised to some power is 9. What is that power? 2, right? So this is simply 2. Because 3 squared is 9. You could do the same thing for the other one. Log base 3 of 27. I could do it because I notice that the base is 3 and 27 is a power of 3. That's 3 cubed, right? 3 to the what power is 27? 3. So plus 3. This whole thing right here is just 3. And therefore 2 plus 3 is 5 and I'm done. Same answer. And I just thought of another way I could go with it, so I'm going to go ahead and show you guys that way as well. We're going to get the same answer, it doesn't matter, but actually we're using a lot of different properties, so this is good. Here I use the product property, right? Adding two logarithms with the same base means multiplying those numbers. Here I just went ahead and used the definition of logarithm to simplify this one down to 2 and this one down to 3 and then added them. What I'm going to do now is this one. I am going to write the 9 here. I notice that it's a power of 3, so I'm going to write it as 3 squared. So this is log base 3 of 3 squared plus, I'm going to do the same thing to the 27. Log base 3 of 3 cubed. It's a lot of 3's right there. And then what I'm going to do is I'm going to take this power here and bring it to the front, right? I can do that. So I'm going to write it as 2 log base 3 of 3 plus 3 log base 3 of 3. And then I notice here that I have the same base with the same input here. And one of the properties that we have up here, let's look back up here, says that if you have the same base right there and the same number here, same input, same base, you're going to get 1 every single time, regardless of what that base is. Same base, same number, you get 1. So let's go back. Log base 3 of 3 is just 1. So this basically means 2 times 1. 2. Same thing here. Log base 3 of 3, that's just 1. So this just means 3 times 1. So that's 5. Same answer, different ways. Right? You should end up at the same answer as long as you're using all the properties correctly. You're going to end up at the same spot regardless of which way you go. Okay, I'm going to let you guys work on these 4 on the back side. 6, 7, 8, and 9. Those are all yours. Okay, so take a few minutes to work on them on your own. Please struggle with them yourself. Go back and look at some of the properties. Go back and look at some of the examples if you can of that I just did. Look at your work that you just wrote as you were following me along and see if you guys can figure them out on your own before you check the answers. Okay, so go ahead and pause the video right now. Come back to check your answers. Okay, so if you're ready to see the answers, here's number 6 and number 7. Both of these I think were fairly simple. Number 6 says log base 2 of 80 minus log base 2 of 10. So what I did is I noticed that there was a subtraction of two logarithms with the same base. So I used that property, the quotient property that we saw before, and we used it to put them together. Same base, but now divide 80 by 10. 80 divided by 10 turned out to be 8, so it's just log base 2 of 8. And at that point, I used a little bit of mental math to think, put this in exponential form to solve it. The way you think about this is 2 to some power is equal to 8. What is that power? 3, right? 2 cubed is equal to 8. So this whole thing is just 3, okay? If you don't see it that way, the way that I did it with mental math, then what you should do is write log base 2 of 8 is equal to x, or some variable of your choosing. And then what you do is you write 2 to the x equals 8. And so then it's 2 to the x equals 2 cubed, because 8 is 2 cubed. And now you see it, x is equal to 3. Your solution is 3. Okay? But it was simple enough, I think, that you guys could have done in your head. 2 to the power of what is 8? 3. Number 7 is much simpler. What I did in number 7 is I took the 6 and I brought it to the front to write 6 log base 4 of 4. See that? All I did was took the 6 to the front. And then I remember the property. It's in your tables up there with the definitions. Anytime you have the log with the same base and the same input number here, base 4 of 4, that's just 1. It's always going to be 1 regardless of what these numbers. As long as these two numbers are the same, you're going to get 1 every single time. So that means it's just 6 times 1, which is 6. Done. Alright, and scrolling down to 8 and 9, here's the answers for 8 and 9. For number 8, here's what happened. I took log base 12 of 1. I set it equal to some number x, right? I just picked a random variable. You could have chosen y. Changed it to exponential form, so it's 12 to the power of x equals 1. And then I use my knowledge of exponents to say, what do I need to raise this to what power do I raise it so I could get 1? And you should have come up with 0, right? Anything to the 0 power is always going to be 1. So it's 0. Or, if you didn't want to go that way, this is actually defined up in your definitions. So look back at the front page, and it says here, right here, look at this one, that the log of 1 is 0, regardless of b. Doesn't matter what b is, the log of 1 will be 0 every single time. So that's basically the way you could think of log of 1, regardless of b, is going to be 0. Number 9, a little bit tougher, but you should have been able to solve it. Log base 2 of 1920 minus log base 2 of 30. What I did is I put them together using that same property that we keep seeing. 1920 divided by 30, right? Keeping the base the same. 1920 over 30 turned out to be 64. Let me zoom in. It's kind of tough to see here. Turned out to be 64. So it's log base 2 of 64, which gave me 6. And if you're asking yourself, how did you get 6? Here's what I did. I took this, set it equal to some variable x, then changed it to exponential form. 2 to the x power equals 64. Then I noticed that 64 is a power of 2. It is 2 to the 6th power. And therefore x equals 6. So this is just going to be 6. Alright, and that concludes all of the examples for this section. So now it's on you. Go ahead and get started on the homework, which is right here on the right hand side of the back page. Okay, you should be able to now, after all these examples that I've done for you guys, you should be able to figure all of these out. Okay, so go ahead and try your best.